Let me see, where is it? This is my thing. Okay, so there is a live here. Okay, then let me see. This guy goes to this one here. So this is 9. D. This goes like D, I think. So, the page number is same. We still work on this one. Is it okay? Save. I hope my voice is working. Yeah, I think it's working. So then we have to go to, this is another YouTube, so we can go to whiteboard because my old whiteboard was expired. So I have to make a new one. So we do just the same coordinate as before, yeah? So we have, this is E1 and this is E2. Then we have tilted E1 prime, this is theta, and this way we have another coordinate E2 prime, this is also theta. Then we now have to consider different triangle like this. So that means I make this way, this way, this way, this way, this way. Strange. So this way, right? So then we call OAB. So we call OAB. This is what we call OAB, right? Then we have 3 forces. This here, maybe force 1, force 2, and force 3. Then we also have normal vector. This is like N1, this is N2, and this is N3, right? So then we have stress tensor. So now we have lengths. We let AB, this is 1. So AO, what is this? This is a theta, right? This is a theta. So AO is sine theta. Then OB is cosine theta. This is the length. Yeah. Then T. Remember T was force density. Right? T. So we want to calculate F1. F1 is actually a vector. Then there is a length, is sine theta. Then there is a stress tensor. Stress tensor goes like sigma xx E1 plus sigma. What was this? Sigma yx. I forgot. yx e2. I'm sorry, I kind of forgot. Let me see. I don't keep the textbook. Let's see. Where's our textbook is here, right? This is our textbook. Let me see. Let me open the textbook. So this goes like the problem is this textbook doesn't show the important definition. That's a big problem here. Let's see, here is xy. We go x. This guy is xy. So this is f1. Then we can go also f2. F2 is now you have opposite direction, so you have minus sign. Then there's a cosine. This is the length. This is cosine theta. Then there's a stress function, which is sigma yx e1 e1 plus sigma yy e2. Then the third one, we better use a primed coordinate for F3. So actually F3, the direction could be tilted. Right? But normal vector, this normal one, this is this direction, E2 direction, E2 prime direction, right? So this is E2 prime direction, positive. So it's you can use the same formula as above. So F3 goes like this. You have, first of all, the length is 1. Use a primed tensor. So yx prime e1 prime. This goes like prime plus sigma yy prime e2 prime, right? So then we can convert e1, actually e1 prime is like this. Cosine cos theta e1, yeah, plus sine theta e2, correct? So e2 prime is minus sine theta e1 plus cosine theta e2. Yeah, so we have to put this expression here, right? So what do we have? what do we have? It's complicated. Yeah. Sigma yx prime E1 is cos theta E1 plus sin theta E2 plus sigma yy prime minus sin theta E1 plus cosine theta E2. Yeah. Then we put two E1 together. So we have sigma yx prime cosine theta and minus sigma yy prime sin theta E1 plus sigma yx prime sin theta plus sigma yy prime cosine theta E2. This way. Then we have force balance equation, which is F1 plus F2 plus F3. This is 0. This is force balance. So we apply to both directions. Let's see. We consider this E1, 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 this direction. So we have this one. Sigma yx prime cosine theta minus sigma yy prime sin theta. Then we have this sin theta sigma xx plus sigma xx sin theta minus sigma yx cosine theta equals 0. Okay. That's from E1 part. Then let's see, we do E2 part. Here, here. Then we have E2 part here. So then we have force balance here too. So that means sigma yx prime sin theta plus sigma yy prime cosine theta. Yeah. Then we have plus sigma xy sin theta plus sigma yy cosine theta. It seems here is minus. We have minus. And this is equal to 0. This is equal to 0, right? So now we can simplify. So this is like a cos theta minus sin theta, sin theta, cos theta. And then we have sigma yx prime, sigma yy prime. Yeah, so this is equal with a sign change, so it's very complicated. Minus sigma xx sin theta plus sigma yx cosine theta minus sigma xy sin theta plus sigma yy cosine theta. Yeah? Then we have to multiply something, right? I think we should multiply cosine theta sine theta minus sine theta cosine theta. What happens if we multiply cosine sine? I think this should work, right? So we multiply same thing here. Cosine theta sine theta minus sine theta cosine theta. So then this side, you can this go to identity matrix. So the final answer we obtain is like this. Sigma yx prime sigma yy prime. This goes like this. It's a little bit complicated. How do we calculate this? Minus sigma xx sine theta cosine theta plus sigma yx cosine theta cosine theta. Then minus sigma xy sine theta square plus sigma yy cos theta sine theta. Am I correct? And the bottom downstairs bottom line we do sigma xx. I think this should be xx. Correct? Sine square minus sigma yx cos theta sine theta. Then sorry, I think it's okay. So then minus sigma xy sine theta to sine theta. Yeah, then sigma yy cosine square theta. I think this is correct. So then how we organize x, y, what is that? X, y. So we do this. Let's see. 2. Let's look at this. 2 is y. Y is this one. So y part is sine square minus plus cosine square. Yeah? Just see. 1, 2. 1. This is 1. This is 2. Sine square cosine square. Sine square cosine square. Yes, minus 2, 1, 2. Minus 2, 1, 2. Sine square, sine theta, cosine theta. So this is okay. We are done. So now we go to 2, 1. 2, 1 is this one, right? 2, 1, we check. 2, 1 part is 2, 1, 1, 2. This is 2, 1, 1, 2. This is 2, 1, 1, 2. Yeah. Cosine square minus sine square. Cosine square minus sine square. Then 1, 1 minus 2, 2. Here. 1, 1 minus 2, 2. Then there is a sign here. So we have sign here. Then 1, 1 minus 2, 2. Sine theta, cosine theta. So this is correct. So now we derived this whole 4 equation. We are successfully derived 4 equations. Well, we have so now we don't have to worry about this rotation. Then this system can be written in terms of matrices as. I think this should be an exercise to people. Or something. But I think this is kind of too much. So let me stop here. We finish equation 283 by this video. Okay, so here I finished number D video. Here I finished equation. This one we finished. Here we finished. Okay.